Welcome to Tech Talk with Beanie.
Have you ever stopped and wondered what actually holds our world together? Not just physically, but intellectually, creatively, and technologically? Because when we look at the greatest achievements from humanity, from rockets to robots, from skyscrapers to symphonies of design, from space travel to digital art, underneath all of it, we find two subjects quietly shaping everything: mathematics and physics. And the truth is, we really cannot live without them. Mathematics and physics are not just school subjects. They are not just equations in a textbook or formulas on a whiteboard. They are the language of reality itself. They are the reason we can build, predict, create, innovate, and imagine futures that once seemed impossible. Let's start with mathematics. Mathematics is the structure behind logic, patterns, measurement, proportion, and systems. It allows us to describe relationships in a way that is precise and universal. No matter what language you speak, a mathematical truth remains the same. 2 plus 2 is still 4. Geometry still governs shape. Calculus still describes change. Statistics still helps us understand uncertainty. Then there's physics. Physics is the study of how the universe behaves. It explains motion, force, energy, light, gravity, time, electricity, and matter. Physics tells us why planets orbit stars, why bridges stand, why aircraft fly, why batteries work, and why your phone can communicate wirelessly with someone across the world in seconds. If mathematics gives us the language, physics gives us the story of reality written in that language. And when the two come together, civilization advances. Think about engineering. Engineering is, in many ways, the practical child of mathematics and physics. Engineers take the laws of nature, combine them with mathematical precision, and turn ideas into reality. Every road, every medical device, every airplane, every data network, every satellite, every power grid, every machine, all of it depends on these two disciplines. Without mathematics, engineers would have no reliable way to calculate loads, optimize systems, model performance, or control risk. Even something as ordinary as turning on a light switch represents generations of mathematical reasoning and physical discovery. Now let's talk about futurism. Futurism is often associated with bold visions, artificial intelligence, space colonization, clean energy, high-speed transportation, robotics, biotechnology, quantum computing, and worlds that feel almost science fiction. But futurism is not built on imagination alone. It's built on what mathematics and physics make possible. Autonomous vehicles rely on geometry, probability, control theory, and physics. Space travel depends on orbital mechanics, propulsion, thermodynamics, and advanced modeling. Renewable energy depends on electrical physics, material science, and optimization. Artificial intelligence depends on linear algebra, statistics, calculus, and computation. The future does not emerge from wishful thinking. It emerges from deep scientific and mathematical understanding. That is why the people who shape the future are often the ones who respect fundamentals. Look at Sir Isaac Newton. Newton helped formalize calculus and explain the laws of motion and gravity. His work did not just change science, it changed human civilization. He gave humanity tools to describe how objects move, how forces act, and how celestial bodies behave. That foundation still shapes engineering and aerospace today. Then there's Albert Einstein, whose work on relativity reshaped our understanding of space, time, gravity, and energy. Einstein showed us that reality was stranger and more beautiful than what most people imagined. His ideas were deeply mathematical, yet they transformed physics into something almost philosophical. You can also think about Galileo, who pushed science toward observation, experimentation, and mathematical description. He helped move humanity away from guesswork and toward measurable truth. And then there is Leonardo da Vinci, one of the greatest examples of the unity of art, engineering, and science. Leonardo did not separate beauty from mechanics. He studied anatomy, motion, geometry, and structure because he understood something powerful. Art becomes deeper when it understands reality, and engineering becomes greater when it's guided by imagination. When painters learned linear perspective, they were using geometry to create depth. When architects design beautiful buildings, they are blending structural physics with visual elegance. When musicians compose, they are often working with ratios, timing, frequency, and wave behavior. When digital artists create animation, 3D rendering, or visual effects, they are using mathematical transformations and physical simulation. Even nature's beauty is mathematical. Snowflakes, spirals, honeycombs, waves, branching trees, planetary motion, and the proportions found in living systems all reflect mathematical and physical order. That is why art inspired by nature often feels timeless, because nature itself is written in these patterns. This is also why some of history's most brilliant minds move fluidly between science and art. Johannes Kepler studied planetary motion, but he was also captivated by harmony and geometric beauty. Michelangelo mastered the human form through deep observation of structure and anatomy. Buckminster Fuller explored geometry, architecture, and future-facing design in ways that still influence modern thinkers. Mathematics teaches us how to think clearly. Physics teaches us how the universe works. Engineering uses both to solve real-world problems. Art uses both to express beauty in deeper ways. Futurism depends on both to turn dreams into systems that actually function. This is why the future will always belong in part to the people who respect fundamentals, to the people willing to learn the equations. If we want to build a better future, we cannot abandon mathematics and physics. We have to embrace them, because the future is not built by guessing, it is built by understanding.
Bloopers. This isn't going well. Oops. Try that again.
Okay, well, hold on. You want me to say the title like that? Okay. Oh, wait. Well, can you go for a little bit? Oh. Not just physically, but intellectually, creatively. Oh my god, this is gonna be a painful one. I messed up. Autonomous vehicles rely. Then there's Albert Einstein. I messed myself up. Should I redo that? Almost. Why do I replace words like that? That's just my brain doing that. Leonardo, right? When musicians compose, they're often working with ratios. I'm British. This is why some of the most... Well, oh my goodness. This is also why. Okay, this is also why. What am I doing? Fluidly. Okay. Oh, I almost fell. Okay, I'm good. Buckminster... It just sounds weird to say that. Okay, let me keep it. Sorry. Continue to prove that technical. That's it.
Thank you for watching, and see you next time.